Hi guys, McGregor Card here, and in this video we are going to be going over bidirectional D-Shot and RPM filtering. This is some advanced stuff and can seem daunting, but as always, we're going to try and break it down for you. First off, what is bidirectional D-Shot? D-Shot stands for Digital Shot, which is a digital communication protocol between your flight controller and electronic speed controllers, or ESCs. It is how your flight controller tells your ESCs how fast they need to spin the motors. Normally you will see D-Shot paired together with a number such as D-Shot 150, 300, or D-Shot 600. The number indicates the speed at which data is sent to the ESC, measured in bits per second. So D-Shot 150 equals 150,000 bits per second, D-Shot 600 equals 600,000 bits per second, so on and so forth. Some older ESCs are only capable of receiving the D-Shot 150 rate, while most modern ones are good with anything between 150 to 600. Generally, the faster or more data that can be transmitted, the better. It will give your motors better resolution and smoother response to inputs. Bidirectional D-Shot is a new feature that was added to Betaflight 4.1 that allows bidirectional communication between the flight controller and the ESCs. It allows the flight controller to read in near real time the RPM of each motor. It requires Betaflight 4.1 or above, and also requires that the ESCs be running supported firmware. That brings us to RPM filtering. With RPM filtering, the flight controller will know what RPM each motor is spinning at and can accurately and dynamically adjust the filters up or down to help eliminate a lot of the vibrational noise created by each motor. This helps greatly with prop wash handling and all-around performance of your drone, so it's highly recommended to enable bidirectional D-Shot and RPM filtering. Now in this course, one of the drones we recommend is the Emax Hawk Pro, which can support bidirectional D-Shot and RPM filtering. So let's go ahead and show you how to set this up. First off, we need to make sure that the ESC is running the latest firmware that supports bidirectional D-Shot. So we will need to download BLHeli Suite 32 Configurator to update the ESCs. To get the BLHeli 32 Suite Configurator, follow the link below. Once there, find where it says BLHeli 32 Downloads and click on the Google Drive link. You will need the file BLHeli Suite 32 32714.zip for Windows, or BLHeli Suite 32 XM Mac OS 64 1004.zip if you are running Mac OS. Download and unzip the file, then go to where you unzipped it and run the BLHeli Suite 32 program. To update to the latest ESC firmware, you will need to remove your props, plug in a battery to your drone, then plug in a USB to the flight controller. For safety, make sure you take your props off before you plug in the battery. Also, make sure you have a video transmitter antenna installed. Go ahead and plug in the battery, wait for the startup beeps to stop, then plug in the USB. In BLHeli Suite 32, hit connect, wait a few seconds, then click Read Setup. You should get a dialog box with your ESC information that should look like this. If the box is empty, try clicking the Read Setup button again. Take note of the firmware version. You will need to be running version 32.7. Go ahead and click on the Flash BLHeli button. Select version 32.7 and hit Flash Firmware. This will take a minute or two. Make sure it flashes to each ESC. If it doesn't, you may have to select each individual ESC to flash it. After you're done, click Disconnect and unplug the USB and the battery from your drone. Then plug the battery back in, then USB, and then click Connect and then Read Setup again so that we can confirm that all the ESCs were properly programmed with BLHeli version 32.7. If everything looks good, click Disconnect and unplug your drone. Now let's move over to Betaflight and get the RPM filtering set up. Before you start, you will need to count the number of poles or magnets on one of your motors. The ESCs report RPM data as eRPM. Betaflight needs to convert this to RPM, and to do this, it needs to know the correct number of poles on the motor. Most 5-inch drones have 14 magnets in each motor, but it's good to double check. Use a marker or a small piece of tape to mark magnet 1, then rotate the motor bell and count all the magnets. If you have less or more than 14, write down the number and save it for later. Now at this point, you should already have Betaflight installed. Go ahead and start it up. If you see a prompt to update, follow the on-screen instructions to install the latest version. With Betaflight open, connect your drone with the USB cable, then hit the connect button. click on the Configuration tab and under the ESC/Motor Features section, click the switch to enable bidirectional D-Shot. Then make sure you have the correct number of motor poles entered. While we're here in the Configuration tab, we also need to set the ESC motor protocol and the gyro update frequency/PID loop frequency. RPM filtering is a little bit processor intensive, so we need to set these settings accordingly. Since the processor on the Emax Hawk Pro flight controller is an F4 processor, we need to set the ESC motor protocol to D-Shot 300, and both the gyro update frequency and the PID loop frequency to 4K. These settings will increase reliability and lessen the load on the processor. Now click Save and reboot. Click Connect again. We can verify that bidirectional D-Shot is now working over in the Motors tab. With props off, connect a battery. You will see that under each motor is a reading for RPM and errors. With no battery plugged into the drone, there will be 100% errors because there is no ESC data being sent to the flight controller. When you plug in the battery, the errors should drop down to 0%. This will indicate that bidirectional D-Shot is working properly. Now you can even make sure that the RPM data is being reported by testing the motors. First, make sure your props are off, click the switch to enable motor testing, then use the master slider to spin up the motors a little bit. You will see RPM information under each motor. Stop the motors, click the switch to disable the motors, then unplug the battery. Now go over to the PID tuning tab and click on the filter settings. Go down to the gyro RPM filter section and make sure the switch is enabled. It should be turned on by default when you enable bidirectional D-Shot. We will need to adjust a few of the filter settings now that the RPM filtering is going to be doing a lot of the filtering work. In the gyro RPM filter section, you'll want to set the gyro RPM filter harmonics number to 1. This will make it so that the RPM filter is focusing on just the noise produced by the motors and nothing else. Next, we are going to adjust the dynamic notch filter. A notch filter rejects or attenuates signals in a specific frequency band called the stop band frequency range and passes the signals above and below this band. Because it's a dynamic notch filter, this means that it can move and target vibrational noises within a specified range. With RPM filtering enabled, we don't need the dynamic notch filter looking for and trying to filter out motor noise anymore. So we adjust the parameters to ignore motor noise and focus on filtering out any other sources of noise that might appear. Set the dynamic notch range to low, the dynamic notch width % to 0, the dynamic notch Q to 200, and the dynamic notch min hertz to 90. With those changes made, go ahead and click Save, disconnect, then unplug the USB cable. Now go out and fly a test pack. The drone should be flying smoother and handling prop wash better. There is still a little bit of filter tuning you can do to make your drone fly even better. We talked about how to do this in the previous filtering video, so if you need a refresher, go back and watch it again. If you have any questions, definitely let us know and have fun flying.